Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this general science physics, we have completed a lot of topics. Recently, we have completed friction, surface tension topics. Okay, so in this session, we are going to discuss remaining mechanical quantities: viscosity, elasticity, strain, stress, all those. Okay, so if you want previous, you can click on playlist, you can find out the previous session. And some of the students just opening the video and just skipping. So if you just open and skipping, you may not get anything. Okay, so if you watch 2 to 3 sessions completely, then only you will get understand. Okay, so all this we have completed now: friction, surface tension. Now another important in this mechanical terms, that is capillarity. That is capillarity. What is meant by capillarity? Capillarity is the property of the liquid that will be rise or fall whenever we dip into the capillary tube. So if we dip any capillary tube into the liquid may be rises or falls. That concept is capillarity. That concept is capillarity. Okay, so for example, if I have taken some amount of the water, okay, if I have taken some amount of water in any container, if you dip any one capillary tube into that, then this water level rises in the tube. Water level rises in the tube, and here you are getting the shape. You are getting the shape is like this. So you will get concave type of the shape. So rise of water, observe the rise of water in the capillary tube. So if you can consider same in the mercury, if you take any one container, here I have taken mercury. If you take the mercury, if you dip one capillary tube here, one capillary tube here mercury level falls. Mercury level falls to this. Here the shape of meniscus is called as convex. Convex. So here what is happening? In case of water, rise of water occurs in the capillary tube. Here in case of mercury, fall of liquid. Fall of liquid, that is fall of mercury level in the meniscus. Okay, so this rising or falling of the liquid when we dip into the capillary tube is nothing but can say capillarity principle. Capillarity principle. Okay, you can note down here what is this capillary tube, sir? These are capillary tube. That means a narrow diameter, small diameter tube is nothing but can say capillary tube. You can note down here capillary tube is nothing but narrow diameter pipe or tube. Narrow diameter tube is nothing but capillary tube. So note down here what is the capillarity? The phenomena of rise or fall of liquid is nothing but we can say capillary tube, capillarity. Okay. So the phenomenon of rise or fall of liquid in capillary tube capillary tube, liquid capillary tube, when it is dipped into liquid. When it is dipped into liquid, liquid is called capillarity. Capillarity. Okay, this is due to surface tension. Due to surface tension principle. We know very well surface tension, force acting on unit length. Okay, so this is always tries to water will be rise. Mercury may be false. Okay, mercury may be false. So the phenomena of rise or fall of liquid in a capillary tube when it is dipped into the liquid is called as capillarity. So here we have to dip into vertically. You want to say vertically, not horizontally. Okay, liquid vertically. Vertically is called as capillarity. Okay, so here note down the 2 points here. Capillary tube is nothing but a narrow diameter tube, and here the height or fall, the height of liquid either rise or fall in a capillary tube is depends upon its diameter or radius. Depends on radius or diameter of the tube. Okay, if diameter increases, then rise of the liquid is going to be false. Okay, rise of the liquid is going to be false. If dia is double, rise of liquid is off. Liquid is off. Okay, it is general phenomena only. If you place very large diameter, then automatically rise of the liquid is decreases. Okay, so this is also very important point. Very important point. And coming to these 2 points, here concave shape, here convex shape. So water concave, in case of mercury convex shape. So note down 2 important notes. First point, if a capillary tube dipped into the water, what happened? If you dip into the water level rises. Okay, water rises in the tube, and shape of water meniscus is shape of water meniscus is, it's a shape in the water, concave shape. Okay, concave shape. This type of shape you got on the top of the tube. And second one, if a capillary tube dipped into mercury. Mercury level falls na? It falls in the tube and the shape of meniscus is convex shape. Okay, outer side of the spoon. Concave, inner side of the spoon. Okay, inner side of the spoon. So this is the capillarity principle. Okay, capillarity principle. Example, roots of plants absorb groundwater. Okay, roots of plants absorb the groundwater due to capillarity principle. Capillarity principle. Correct? So here if you can consider, this is the surface of the earth. Here into the earth, roots of plants are present. Okay, so if here we have the groundwater, then what will happen? Each root will be act as the capillary tube. Okay, each root will be act as the capillary tube. So whenever capillary tube is dipped into the water, what will happen? Water level rises. So in this phenomena, it will extract the water. And for example, any wick kerosene, for example, let us take kerosene wick, absorb oil. Okay, for example, if you take kerosene wick, in olden days we are using this one now, and thread is placed in the kerosene bottle. Okay, so here we are getting the fire. Okay, how this thread extract the kerosene? By using the principle of capillarity. Okay, so these are very important examples belongs to capillarity. Now after this, coming to the next topic, after the capillarity, viscosity. Viscosity is same like friction. Okay, it is also opposing quantity. Okay, opposing quantity. So note down, but viscosity is generally a property of the liquid. It is property of liquid. It opposes the relative motion between the different layers of liquid or gases. Different layers of liquid or gases. Okay, so we can also say that which is it opposes the fluid motion. It opposes the fluid or liquid motion. Opposes the fluid or liquid motion. Okay, one note down, liquid, the fluid is also another liquid. So it opposes the liquid motion. It's nothing but we can say viscosity. Okay, viscosity. For example, if you observe in the beach, what is happening in the beach? If it is the middle of the sea, here a heavy waves are heavy water waves. are generated, and those are whenever coming to near to the earth surface, those are subsided. That means those are reduces, and we are where the persons who are in the beach are experience this one, so they are getting a small amount of water waves. Correct. Why? Because here what is happening, whenever the upper layer of the water want to move, the lower layer opposes that one. The lower layer opposes that one, and this layer want to move, this lower layer opposes that one. Okay, so that means here there is a viscosity concept is there. That viscosity is the property of the liquid. It opposes the motion. It opposes the motion in case of liquid or gases. Okay, so that's why these water waves generated middle of the sea is very high, and whenever they coming to the beach, they are reducing subsequently. Okay, in the same way, let us take rainwater. So if these are considered as the clouds, okay, from the clouds to the earth surface, here there is a lot of distance is there. So for example, whenever from third floor, second floor or third floor of the building, if you pour some water, whenever that water will fall on the heads of any one person, he get a small pain. Correct? He get a small pain. But here what is happening in case of raining? There is a lot of distance between the clouds and earth surface. Correct? So if the raindrops are falling from the clouds and reaches to the earth, there is a lot of distance, means there is a lot of energy. Okay, so there is a lot of kinetic energy it has, and whenever they fall on the heads of our heads may be broken, but it is not happen. Our heads are not brokening. Correct? Why? Because in the between of clouds and earth there is a lot of atmosphere is there. In this atmosphere there is a lot of air is there. That air opposes the water motion. That means raindrops motion. Okay, so if want to fall with the high velocity, it always opposes. Always opposes. Okay, so that is because of viscosity of air. Viscosity of air, the waters are water, that is raindrops are falls with less uniform velocity. Less uniform velocity. These are the real-time examples of viscosity. Okay, and note down the important point. Viscosity of liquid. Viscosity of liquid is due to dash force. Here, if the upper one want to move, lower one is opposing. If this lower one want to move, this another lower one is opposing. So whenever there is a opposition, that means one opposing another one. When they will oppose, whenever there is a some attractive force. Okay, for example, here one boy and one girl is there. Both are lovers. If the boy want to move, girl opposes. If the girl want to move, boy opposes. Why? There is a relative attraction between them. There is a attractive force between them. So that's why those are opposing. In the same way, here also there is opposing, means there is a force of attraction between the layers of water. Okay, between the layers of water. So here viscosity of liquid is due to cohesive force. I have already given about the cohesive force in the previous session, which is nothing but force of attraction between the same molecules. Okay, viscosity of liquid is due to cohesive force between molecules. What is the cohesive force? Force of attraction between the same molecules. Okay, viscosity of liquid is due to cohesive force between the molecules. And in the same way, viscosity of gases is due to diffusion of its molecules. diffusion of its molecules. And so that's why cohesive force is very high. So that's why viscosity of liquid is higher than the gases. Viscosity of gases is less that of liquids. Okay, in case of solids, no viscosity. In solids, we have friction. In solids, no viscosity. No viscosity concept. Okay. So if you can consider any ideal fluid, in ideal fluid, what is the viscosity? Viscosity is zero. Is zero. Okay. And coming to how viscosity depends on temperature. Temperature. Effect of temperature. Okay. So in case of liquids, as temperature increases, what will happen? Cohesive force is decreases. Cohesive force decreases, that means force of attraction decreases. Force of attraction decreases means viscosity also decreases. Okay, for example, if you put AC between the AC to the boys and girl, they will be attract and very near to each other. Okay, if you increase the temperature to 50 degrees, then what will happen? They are trying to separate. Okay, so they are trying to sit with some gap. Correct. So that means what is happening? If the temperature increases, the particles expands. That particles moves. Okay, so moves means their cohesive force is decreases. So viscosity is decreases. But in case of gas, it's different. This is not belongs to cohesive force now. So here as temperature increases, viscosity also increases. Viscosity also increases. In this, one more important point is there, that is coefficient of viscosity. Coefficient of viscosity. So many times they will ask this question, denoted with letter zeta, that is equal to sharing stress by velocity gradient. Velocity gradient. Okay, stress force by unit area, na? Velocity gradient dv by dx. Then what about the units? Force Newton per meter square by velocity meter per second dx, distance meter. So meter cancel out. So you will get Newton second per meter square. You see, these are the unit. R Newton per meter square into second na. Newton per meter square into second. Correct? So you can write down this one. Newton per meter square is the Pascal. So Pascal second. Pascal second, Newton per meter square into second are the units of coefficient of viscosity. Coefficient of viscosity. Okay. And we can also give the another units. Newton per meter square into second, or Pascal second, or Pais, or Paisali. All these are units of coefficient of viscosity. Units of coefficient of viscosity. Note down all this. Noted. Okay, so generally Poise is CGS unit. Okay, 1 Poise is equal to 1 dyne second per centimeter square. Centimeter square. Okay, or 0.1 Newton per meter square into second. 0.1 into 0.1 Newton per meter square into second. Okay, or 1 Poiseuille. 1 Poiseuille is equal to 10 Poise. That means 1 Poise is equal to 1 by 10, that is equal to 0.1 Poiseuille. These are the relations between all this. Okay, relations between all this. So from this one, what we can say? Theta is equal to, units are Newton per meter square into second. That is equal to Newton per meter square is Pascal second. Pascal second is equal to, you can say Poiseuille. Pascal second can say Poiseuille. Okay, 1 Poiseuille is equal to 10 Poise. 10 Poise. Okay, so this Poiseuille is the SI unit. Okay, Poise is the CGS unit. So note down some examples. Raindrops falls with less uniform velocity because of viscosity of air. Viscosity of air. Okay. Second one, due to viscosity, high waves on sea are subsided. Okay, and where we use this concept, some applications. Okay, so in case of aeroplanes are moving in the air now, so they has to overcome the viscosity of the air. So design of ships, aeroplanes, motor vehicles design, all are based on this only. And very important, quality of fountain pen. Very important question. The quality of fountain pen depends on viscosity of ink. Correct. For example, if viscosity of ink is low, okay, viscosity is low means opposition is low. Whenever the opposition is low, whenever you put pen on the paper, then what will happen? It will be spreads. Easily. Okay, so that means like a sketch pen. So you can observe the old sketch pen. Whenever you put pen ink, pen tip on the paper, then the ink may be easily spreads. So in this case also you may not get the good writing. The same way, if you can consider viscosity of ink is more, that is more opposition. Opposition is more. Whenever the opposition is more, if you want to write, ink may not spread. Okay, if you want to write, ink may not spread. So you have to put a more effort. If you put a more effort, then also this you can't write fastly. So that is also not important. So that's why viscosity of ink must be within limits. Viscosity of ink must be within limits. So the quality of fountain pen depends upon viscosity of ink. That is another very important application. And characteristics of lubricant oils. Characteristics of lubricant oils. You have to take always oils viscosity as less. Must be less. Then only they can move faster. Then only they can move faster. Okay. And after this, we have to discuss a small thing: velocity. Sorry, after this, elasticity, elastic limit, Hooke's law, stress and strain. After that, we have discussed the modulus of elasticity topics in the next session. Okay, and the students who watch this videos completely will get a good knowledge. Okay, and one more thing, if any topic is not completed in this theory class, no need of worry, that will be completed in the MCQ session. Okay, so after this theory I will take the MCQ sessions also. Okay students, all of you take care. Bye guys.